A function in Python is like a little kitchen recipe that you can use over and over. The recipe starts with the word def, followed by the name you want to give the recipe, a pair of parentheses for the ingredients called parameters, and a colon. After the colon, you write the steps, each indented one level. Def add a b, o, and b are the ingredients. Result equals a plus b, step 1, add them. Return result, give the result back to whoever asked. The parameters are placeholders for the values you will give later, called arguments. Inside the function you can do many things, and when you are ready to hand a value back you use return. If you forget return, Python gives back a special value called none. Think of return as the waiter bringing the finished dish to the table. The syntax is strict def name optional parameters indented block. Anything after the colon must be indented the same amount, otherwise Python will raise an error. This simple pattern lets you hide a bunch of work inside a tidy box that you can open whenever you need. Sometimes a recipe works even if you forget an ingredient, or you want to say, I want the sugar, not the flour. Python supports 3 tricks for this. 1. Default arguments. You give a parameter a value when you write the function. If the caller does not provide that ingredient, the default is used. Define greet with parameters name and greeting equals hello. Return greeting, name. Print greet with argument Alice uses default hello. Print greet with arguments Bob and hi overrides default. 2. Keyword arguments. When calling, you can name the ingredient, so order does not matter. Call greet with name equal Eve and greeting equal hey. 3. Variable length parameters. Sometimes you do not know how many ingredients you will get. Star args collects extra positional arguments into a tuple, and double star quargs collects extra keyword arguments into a dictionary. Define total with star numbers. Return sum of numbers. Print total with arguments 1, 2, 3, 4, which returns 10. Any number of values works. Define describe with double star info. For each key and value in info items, print key : value. Call describe with name equal Sam, age equal 30, city equal Paris. These tools make functions flexible, just like a recipe that can handle optional spices or an unknown number of guests. Explanation : when you write a function, Python needs to know where each name variable lives. It follows the legb rule: local. Enclosing, global, built-in. Local : names created inside the function. Example, the variable x inside def f : Python looks here first. Enclosing : if a function is nested inside another function, the outer function's locals are the enclosing scope. Global : names defined at the top level of the file outside any function. Built-in : names that Python always provides, like len or range. X equals 10 global. Define outer of y inside outer. Z equals 5 enclosing for inner. Define inner of a, return x plus y plus z plus a. Legb finds x global, y enclosing of outer, z enclosing a local. Outer returns inner. Print outer called with 2 then called with 3, result 20. Closures happen when the inner function remembers values from its enclosing scope even after the outer function has finished. The inner function closes over those variables. Define make multiplier of factor. Inside define multiply of n, return n times factor. Factor is captured. Make multiplier returns multiply. Assign triple to make multiplier called with 3. Print triple called with 4, result 12. Factor 3 is still remembered. Think of a closure like a backpack : the inner function carries the needed ingredients variables with it wherever it goes. A lambda expression is Python's way of writing a tiny one-line function without giving it a name. The word lambda means I will give you a function right now. Square equals lambda x times x, same as define square x returns x times x. Print square 5, result 25s. The syntax is lambda to parameters to single expression. Only one expression is allowed. You cannot put statements like if or while inside. If you need more than one line, write a normal defines. No return keyword, the expression's result is returned automatically. No multiple statements, complex logic must be in a normal function. Less readable if overused, especially for people who never saw lambdas. One-line functionality makes lambdas handy for quick throwaway tasks, like sorting by a specific field. People equals list of Alice 30 and Bob 25. People sort key lambda pp second element, sort by age. If you think of a lambda as a sticky note with a short instruction, it's perfect for brief reminders but not for full recipes. Python has several built-in higher-order functions that expect another function as an argument. Lambdas pair nicely with them because you often need only a tiny piece of logic. Map applies a function to each item of an iterable and returns a new iterable. For example, numbers equals list of 1, 2, 3, 4. Squared equals list of map of lambda n colon n squared numbers, which yields 1, 4, 9, 16. Filter keeps items that satisfy a condition. For example, evens equals list of filter of lambda n colon n modulo 2 equals 0 numbers, which yields 2, 4. Sorted can receive a key function to decide how to compare items. For example, words equals list of apple, banana, cherry. Sorted by length equals sorted of words with key lambda w colon length of w, which results in apple, cherry, banana. Reduce from functools combines items using a binary function. For example, product equals reduce of lambda a comma b colon a times b numbers, which yields 24. Mathematically, reduce computes the product of x sub I from I equals 1 to n when the lambda is multiplication. These utilities let you write concise pipelines like result equals sum of filter of lambda x colon x greater than 0, map of lambda x colon x times 2 data. Each step is a tiny transformation, and lambdas keep the code short and focused. In Python, functions are first-class citizens. They can be treated like any other object, numbers, strings. Lists. This gives you 3 powerful abilities. Passing functions as arguments. You can hand a function to another function that will call it later. Define apply underscore twice takes func in value. Return func of value. Print apply underscore twice lambda xx plus 310. Returning functions. A function can create and give back another function. Define make underscore adder takes n. Define adder takes x. Return x plus n. Return adder. Add 5 equals make underscore adder 5. Print add 5 10. Storing functions in containers. You can keep many functions in a list, dict, or set, and call them dynamically. Operations equals square equals lambda xx times x cube equals lambda xx to the power of 3. Print operations cubed 2. These patterns are the heart of functional programming. You build small reusable pieces and combine them in flexible ways, much like Lego bricks. You can attach, detach, and rearrange to build many different structures. Explanation. Good code talks to the next programmer or future you. Python offers 3 tools for that. Docstrings, a triple quoted string right after the def line. It explains what the function does, its parameters, return value, and any side effects. Define a function factorial. Taking n, the docstring says return n factorial. N must be a non-negative integer. If n equals 0, return 1. Otherwise, return n times factorial of n minus 1. Type hints, optional annotations that state what type each argument and the return value should be. They help editors and static checkers catch mistakes. Define a function add with arguments of type integer and b of type integer, returning an integer. The function returns a plus b. Testing strategies, simple assertions can be placed in an if name equals main block, or you can use unitist or pytest for larger projects. Define a function double taking x of type integer, returning x times 2. In the main block, assert that double of 3 equals 6, assert that double of -1 equals -2, then print all quick tests passed. For more systematic testing, write a class that inherits from unitist test case. Import unitist. Define class testmath inheriting from unitist test case. Define method test double that asserts double of 4 equals 8 and double of 0 equals 0. At the end, if name equals main, call unitist main. Combining docstrings, type hints, and tests creates a clear contract. What the function expects, what it returns, and that it works as advertised. A decorator is a special kind of higher-order function that wraps another function adding extra behavior without changing the original code. The syntax uses the @ symbol placed just above the function definition. Think of decorating a cake. The cake original function stays the same, but you add icing sprinkles or a candle on top. Extra behavior. Simple timing decorator. Import time. Define timer open parenthesis func close parenthesis colon. Define wrapper open parenthesis star args comma double star quargs close parenthesis colon. Start equals time dot time open parenthesis close parenthesis. Result equals func open parenthesis star args comma double star quargs close parenthesis call the original function. End equals time dot time open parenthesis close parenthesis. Print formatted string open brace func dot name close brace took open brace end minus start colon dot 4f close brace s close parenthesis. Return result. Return wrapper. Add timer. Define slow sum open parenthesis end close parenthesis colon. Total equals 0. For I in range open parenthesis end close parenthesis colon. Total plus equals I. Return total. Slow sum open parenthesis 1,000,000 close parenthesis. When slow sum is called, the timer runs first, records the time, then calls the original slow sum, prints the duration, and returns the original result. Decorators can also stack. Define bold open parenthesis func close parenthesis colon. Return lambda star a comma double star k colon, quote less than b greater than quote plus func open parenthesis star a comma double star k close parenthesis, plus quote less than slash b greater than quote. Define italic open parenthesis func close parenthesis colon. Return lambda star a comma double star k colon, quote less than I greater than quote plus func open parenthesis star a comma double star k close parenthesis, plus quote less than slash I greater than quote. Add bold at italic. Define greet open parenthesis name close parenthesis colon. Return formatted string quote hello comma open brace name close brace exclamation quote. Print open parenthesis greet open parenthesis quote Bob quote close parenthesis close parenthesis. Decorators are widely used for logging, authentication, caching, and more. They let you separate what a function does from how it is managed, keeping code clean and reusable. Both regular functions def and lambda expressions create callable objects, but they have different performance and readability characteristics. Creation cost. Defining a function once at import time is cheap. Lambdas are created each time the surrounding code runs, which can add a tiny overhead in tight loops. Execution speed. Once created, a lambda runs just as fast as a normal function because both are compiled to Python bytecode. The difference is usually negligible. Readability. A well-named def communicates intent, especially for logic that spans more than one line. Lambdas shine for short throw-away operations. For example, key equals lambda x colon x dot id. Overusing lambdas makes code harder to understand. Debugging. Functions have a proper name that appears in tracebacks. Lambdas show up as lambda, which can be vague. When to choose. Simple one-liner used once, for example, sorted key equals. Prefer lambda because it is concise, no need for a separate name. Reused logic more than a line or needs documentation. Prefer def because it gives a clear name, docstring, and type hints. Performance critical inner loop that creates many callables. Prefer predefined def stored in a variable to avoid repeated lambda creation. In most real-world programs, the difference is microseconds. Choose the style that makes the code easiest for humans to read and maintain.